Hello everyone, welcome back to the OpHaxor YouTube channel. Today we're going to be going over LeetCode problem 872, leaf similar trees. So let's go over the problem statement first. Consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. So as it states here, the leaf value sequences in this tree is 6, 7, 4, 9, 8. It's basically just the leaves in order from left to right. So two binary trees are considered leaf similar if their leaf value sequence is the same. So we have to create a function that returns true if and only if two given trees with head nodes root 1 and root 2 are leaf similar. So let's look at the first example. We have these two trees. We can see that they are different, and we can also see just visually that they are leaf similar. So yeah, 6, 7, 4, 9, 8. This one's also 6, 7, 4, 9, 8. Again, if two trees are the exact same, then obviously they are leaf similar. Like these two trees here. This one, they each just have one node of the same value. The second tree, they're different. There's one node in each tree, and of course one leaf in each tree. So they are not leaf similar. And for example 4, these two trees are leaf similar. One is the root, and the only leaf is 2. And it is the right child, so that is leaf similar. Example 5, not leaf similar because they are not in the same order. Alright, so now we're just going to jump straight into the solution. So I have my main method here where I instantiate some of my variables. I have my root 1, which is instantiated with these values, and this I get straight from the example from the LeetCode website, and I have that on the bottom right corner. The negative ones here are equivalent to the nulls that are in the original example input. I have a insert level order function here that creates a tree node out of these inputs. And then root 2, same concept. It's the second input in the example that's given in the problem. So what we do here, and this is the solution that's taken from our solution on OpHaxor. It's just modified a little bit so I can have some of these print statements so we can understand this better. So we can go ahead and take a closer look at this solution. So it's DFS, so we're using a stack, and of course we want depth from left to right because that's what matters here. So what we're essentially doing here is in leaf similar, we instantiate two stacks, and in each stack the root of root 1 is pushed to the first stack and root 2 is pushed to the second stack, right? And then we have a while loop which checks that none of the stacks are empty, and then we run our DFS function on each of the stacks, right? So what this function does is it runs through, it pops from the stack and it runs through until one of the nodes does not have any children. So until one of the nodes is a leaf. And then if a node is a leaf, that value is returned. DFS is also called on the second stack, same operation. So it runs through the stack, pops, and returns the value of the first leaf that it encounters. So what this ends up being is that it runs from all the way to the left side of the tree to the right and returns the leaf values, right? So what we're going to do here is do a quick debug, right? So we push to our stacks, and then DFS is called on root 1, right? So we can see on the bottom right that the first leaf is 6. So root 1 DFS returns 6, and DFS on the second stack, first leaf is also 6, so that returns 6. Now, let's take a closer look at the functions themselves, at the DFS function itself, just to see what's going on. Right. So right now we have S with the roots of the left-hand tree. So we have value 3. So that's popped. It has a right child, which is 1. That's pushed. Has a left child, 5. That's pushed. And of course, it does have both children. And so 3 is not in the stack anymore, and we have 1 and 5. 5 is on top of the stack, so that is popped first. And then of course 5 has 2 children, so we insert twice. And then we have this node 6. So we can see 6 has no children, so that does not happen, that does not happen, and of course left is null and right is null, so we return that value, right? So that's what's returned. And then same thing for the right hand tree, 6 is returned, right? We just jumped into a debug, or into the breakpoint. Let's go here. Alright, yeah, so we can see root 1 DFS value is 6, and then we compare them. Obviously they're the same, so we don't return false. And it's the same thing. The stack is run through. Each time a leaf is encountered from left to right, they're returned. So it ends up comparing each of the leaf values from left to right for both trees. And that's the basis of the solution. So I'm just going to run the whole thing, and we can see that's what happens. 6 is compared, 7 is compared, 4, 9, and 8. And that is basically it. It's pretty simple once you really look at it. We take advantage of the stack paradigm and of course depth first search. And of course we have our problem and solution posted and detailed on the OpHaxor website. This is the solution that we went over for Java. We also have C++ and Python solutions available. Thank you for watching our video. Be sure to visit OpHaxor and have a great day.